All right, we've got questions 13 through 24, so we're going to finish up the multiple choice here. Question 13. Which value of x satisfies this equation? Well, this is a little tricky. I'm just going to use my calculator. That's going to make life a lot easier. If I go to my calculator, I'm going to do alpha y equals option 1. I'm going to type in 5 over 6, and then the parentheses, alpha y equals number 1, 3 over 8, minus, now it says x. I'm going to substitute in choice 1, negative 19.575, and let's see if I get 16. No, not my answer. So I'm going to do it again. Now, here's a little trick on the calculator. If you hit second enter, it copies everything down. So all I'm going to do is I'm going to go back and change the value of x. So I'm going to type in a negative 18.825. Everything else stays the same. Let's see if that gets me a 16. Yes, it does. There's my answer. Beautiful. Question 14. If the population of 100 cells triples every hour, which function represents P of t, the population after t hours? If you recall this formula, y equals a times b to the x. A is your starting amount. We started with 100, so we want to have 100 in front. B is what you are multiplying by. And because we triple every hour, we are multiplying by 3. So that's where your answer comes from. It's choice 2. 100 is what I'm starting with. 3 is what I multiply by every time. There's my answer. Question 15. A sequence of blocks is shown in the diagram below. This sequence can be defined by the recursive function a of 1 equals 1 and a of n equals that. Assuming the pattern continues, how many blocks will there be when n equals 17? So here's what you want to think about. This first diagram, that's n equals 1. It's my first diagram. This is n equals 2, n equals 3, n equals 4. I'm going to keep going. N equals 5, n equals 6, n equals 7. They want to know how many blocks will they be when n equals 7. I'm going to see if I can figure out the pattern and just keep it going until 7. I'm not even going to use this formula because it doesn't make sense to me. Well, here I have 1 block. Here I have 3 blocks. Here I have 6 blocks. And here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 blocks. So I want to look for the pattern. Well, to get from 1 to 3, I'm adding 2. To get from 3 to 6, I'm adding 3. To get from 6 to 10, I'm adding 4. Interesting. Can we see the pattern that's happening? To get from here to here, what do you think I have to add? Well, I added 2, 3, 4. Now I have to add 5, which would mean I would have 15 blocks. To get to the next one, keep the pattern going. I'd add 6. That gets me to 21. Keep the pattern going. Add 7. That gets me to 28. And that's my answer. Remember, a sequence is all about a pattern. See if you can figure out the pattern and just keep it going. Looking at 16. Mario's $15,000 car depreciates in value at a rate of 19% per year. The value after t years can be modeled by the function this. Which function is equivalent to the original? Okay, we actually did one like this the other day. Here's the function that they're giving me. What are they asking? Which function is equivalent to the original? Get that calculator out. Y equals. I'm putting the equation they gave me. 15,000, oops, type it incorrectly. 15,000 times 0.81 raised to the x. Now I'm going to type in option 1. 15,000 times 0.9 raised to the 9x. And I'm going to go to my table and see if they're the same. And it looks like they're not my answer. So now I'm going to go back to y equals. The first one stays in there. Now I'm putting choice 2 in. 15,000 times 0.9 raised to the 2x. Let's see how that looks. Now when I look at the table, they are matching. They're exactly the same every single time. So that's the answer I want to go with. This equation and this equation are exactly the same every single time. So there's my answer there. All right, let's see what 17 brings us. The highest possible grade for a book report is 100. The teacher deducts 10 points for each day the report is late. Which kind of function describes this situation? First of all, if the highest score is 100, if your teacher deducts 10 points each day, what is she doing? She's subtracting 10 each day. That's the key to this whole problem. She is subtracting 10 each day. Well, exponential means that you're multiplying. So exponential means you are multiplying each day. That's not us. Get rid of it. Quadratic means you have an x squared. Do we have anything getting squared here? No. Get rid of it. Linear, this is when you have something that you are adding or subtracting each time. That's us. So that's what you want there. 18. The function h of x, which is graphed below, so this is h of x, and the function g of x are given. Which statement about these functions are true? Well, I can't tell you what's true until I know what this function looks like. So I'm going to get my calculator out, go to y equals, clear these, and I'm going to type this in. 2 math, go to the right, number 1, x plus 4 minus 3. So that's the equation for g of x. I'm going to go to the table. I'm going to plot some points here and see what my graph looks like. So let's see. I've got -9, -7. I don't think that fits. -8. 1, 2, 3, 4, 5, 6, 7, 8, 5. 1, 2, 3, 4, 5. -7, 3. -7, 3. -6, 1. -5. -1. -4. -3. -3. -1. Oh boy. -2, 1. -1. 3. 0. 5. That's good enough for me. So here's g of x. Okay, let's see. Which statement about these functions are true? G of x, that's the one that I graphed, has a lower minimum than h of x. Well, here's the minimum here. That's all the way down at 1, 2, 3, -3. And here's the minimum here. That minimum's at 2. So g of x has a lower minimum value. Yes, that's a true statement. For all values of x, h of x is less than g of x. If you look at this, so when x is 1, 2, 3, -4, h of x is less than. This means that h is lower than g of x. That's false. G is the graph that's lower. Statement 3, for any value of x, g of x does not equal h of x. That means, are there any, or what this is saying is that there are no points of intersection, which is true. These graphs will never intersect. So statements 1 and 3 are true. That's right there. Tricky, got to do a little work. I don't know if you guys have noticed this, but it seems like the second half of the multiple choice, it gets a little bit harder than the first half. They start us easy and then they step it up a little. 19. The zeros of the function f of x are zeros. This means that y equals 0. So I'm going to go to my calculator. Type in that equation. 2x raised to the third plus 12x minus 10x squared. There's my equation. I'm going to go to the table and I want to find all the places where y equals 0. So I've got 0, 0. Oh, I've got 2, 0. And I've got 3, 0. And it looks like the numbers are just getting bigger from there. So I think that's it. So the zeros are, well, look at, these are all the values where y is 0. So my answers are the x's. So 0, 2, and 3. Question 20. How many of the equations listed below represent the line passing through the points 2, 3, and 4, -7? Okay, I'm using my calculator. The problem is, in order for me to put any equation on my calculator, it has to be y equals. So for this first equation, I have 5x plus y equals 13. I'm going to subtract 5x. Y equals negative 5x plus 13. I'm going to put that on my calculator. Y equals, let's see here, what do I have? Negative 5x plus 13. And I'm going to go to my table. And is the point 2, 3 in my table? Yes. Is the point 4, -7 in my table? Yes. So this line passes through those points, so that's a good one. For the second equation, I have to solve for y so I can put it on my calculator. So y equals negative 5 times x minus 4. All I'm doing is moving this plus 7 to the other side. And of course, when I move it, I subtract it. So I'm going to go to y equals, and I'm going to put this equation on my calculator. And I'm going to check my table. Is the point 2, 3 in there? Yes. Is the point 4, -7 in there? Yes. Okay. Ooh, this one's already in y equals. I can go right to my calculator. Negative 5x plus 13, table. 2, 3, yes, that's there. 4, -7, yes, that one's there. Whew, okay, one more to check. I have to solve for y. I have to move this over. So y equals 5 times x minus 4 plus 7. So I go to my calculator. 5 times x minus 4 plus 7. I go to the table and I look. Is the point 2, 3 on my table? No, it's not. That's the point 2, -3. So this one doesn't count. It doesn't have that point in my calculator. So that one doesn't count. Now look what they're asking. How many of the equations are through those points? 3 of them pass through those points. So your answer for that is how many? So I have 3 for that. A lot of work, but worth it. It's all calculator stuff. 21. The Ebola virus has an infection rate of 11% per day as compared to the SARS virus, which has a rate of 4% per day. If there were 1 case of Ebola and 30 cases of SARS initially reported to authorities, and cases are reported each day, which statement is true? Okay, this one's going to be a little bit of work. SARS. In order for me to do this, I need equations, okay? This is similar to the equation we did a couple questions ago. If I just focus on Ebola, Ebola has an infectious rate of 11% per day, and there was 1 case of Ebola. So Y equals, it started with 1 case, times the infection rate is 11% per day. If you recall, I'm going to jot this formula down to the side. Y equals, we have our starting amount times 1 plus or minus the rate raised to the x. Okay, so 11% is the same thing as 0.11. Because that's going up each day, more people get the virus. So then it's going to be 1 plus that decimal. So look what I fill in here. 1 plus 0.11 is 1.11 raised to the x. Now I have to do the same thing for SARS. Well, there were 30 cases of SARS that started. And the infectious rate, let's see here, that's a rate of 4%. So 4% is equal to 0.04. So of course it's 1 plus 0.04. Remember, the number in the parentheses has to be bigger than 1 because the amount of people that get the viruses is growing. So that's what you want to look at. So now, if we look at this, at day 10 and day 53, there are more Ebola cases. Well, I need to figure out what I have at day 10 and day 53 so I can compare. So I need to do all this work. So I'm going to put my equation 1 times 1.11 raised. For day 10, I'm going to put a 10 up there as my exponent. And I've got 2.839. Now I'm going to do the same thing, but I'm going to put 53 as my exponent because I want day 53. That's my exponent. And I've got 252.416. It doesn't tell me where to round, so I'm just going to jot that down. Now I'm going to go over to SARS and do the exact same thing. 30 times 1.04 raised to the 10. Day 10 raised to the 10. And then do it again. Raised to the 53. 239.821. So now we can compare our information. At day 10 and day 53, there are more Ebola cases. At day 10, nope, that's not true. At day 10, there's more SARS cases. Get rid of it. At day 10 and day 53, there are more SARS cases. So let's go over here. On day 10, there's more SARS. On day 53, there's not. Get rid of it. At day 10, there are more SARS cases. Let's see here. That's true. But at day 53, there are more Ebola cases. So at day 53, there's more Ebola. That's true. 252 is higher than the 239. There's your true statement right there. It's a lot of work, but it's semi-manageable. Tricky, tricky. Okay, just a couple more. The results of a linear regression are shown below. Which phrase best describes the relationship between X and R, or excuse me, X and Y? This is all talking about correlation. You are only looking at the R value. Nothing else matters. R is negative. So first of all, let's get rid of these positive choices. Get rid of positive because it's negative, okay? So now I just need to think, is it strong or is it weak? Well, we know it's negative, so don't look at that. Look at the decimal. Are you closer to 1 or closer to 0? Because close to 1 equals strong. And you're at 0.89, that's going to be strong. Weak would be like a 0.1 or a 0.2 because you're closer to 0. So there's your answer there. That's nice that you don't have to do too much work after everything we just did on the previous question. 23. Abigail and Gina's ages are consecutive integers. Okay, x plus 1. Abigail is younger than Gina. Okay, so then this is Abigail, because she's younger, and Gina. And Gina's age is represented by x. Oh, they're throwing a wrench in this problem. Gina's age is represented by x. Well, based on this, I have Gina as x plus 1. They're telling me that Gina's just x. Well, how do I get rid of the plus 1? I subtract 1. Well, if I subtract 1 from her, then I have to subtract 1 from Abigail. So plus 1 minus 1, those cancel out. Now Gina is x and Abigail is x minus 1. Doesn't this make sense? If I'm 36, my friend is a year younger, she's 35. She's 1 year younger, so I'm just taking away. If the difference of the square of Gina's age is 8 times Abigail's age is 17, which equation could be used? Oh my goodness, so now we're translating. Difference, I need subtraction. The square of Gina's age. Gina is x, I have to square it. And 8 times Abigail's age. 8 times Abigail is 17. Which equation could be used? Let's see if I can find this equation someplace in here. No, I'm looking for an x squared minus 8, x minus 1. That's the choice you want. Okay, last question. We can do it. Which system of equations does not have the same solution as the system below? What you are trying to do is compare what did they do for each of these equations. To get from the first equation here to the first equation here, what did they do to get from 4x to negative 12? They multiplied by negative 3. Did they do that to everything? 4 times negative 3 is negative 12. 3 times negative 3 is negative 9. 10 times negative 3 is negative 30. Yes, that checks. What about the bottom equation? To get from negative 6x to 12, they multiplied by negative 2. Let's see if they did that to everything. Negative 6 times negative 2 is 12. Negative 5 times negative 2 is 10. Negative 16 times negative 2 is 32. Yes. That is a good equation. That's not my answer. I want the one that's not the same. Now I'm going to go through and do the same thing with choice 2. To get from a 4x to a 20x, what happened? Well, they multiplied by 5. So let's see if they did that to everything. 3y times 5 is 15. Yes. 10 times 5 is 50. Yes. Now I check my bottom equation. They went from a negative 6x to a negative 18. So they multiplied by 3. Did they multiply everything by 3? Negative 5 times 3. Yes, that checks. Negative 16 times 3 is negative 48. Everything checks. That's good. So it's not my answer. All right, 2 more. To get from a 4x to a 24, they multiplied by 6. 3 times 6, 10 times 6. Everything checks. On the bottom, negative 6 to a negative 24, they multiplied by 4. So, yes, that checks. Negative 5 times 4, that checks. Negative 16 times 4, that checks. This one checks. That's good. Not my answer. Oh my goodness. Hopefully this one is, there's a problem here. So let's see what's going on. To get from 4 to 40, multiply by 10. 4 times 10, 3 times 10, 10 times 10. That one checks. To get from negative 6 to 36, they would have had to multiply by a negative 6. Negative 6 times negative 6 is 36. Negative 5 times negative 6 is 30. Negative 16 times a negative 6, that should be a positive 96. They made a mistake. That's the problem. That's your answer. All right, now we're done with multiple choice.